Hello and welcome everybody. I hope everybody can hear me. I can see my mic tingling, so that's a good sign. I hope all of you guys are doing good. There's only 9 of us today. Most of the people are busy, I guess. Can't wait forever, so we should begin. One thing before I wanna put out before I begin is, first of all, don't mind the white noise at the back. That's my air conditioner, just trying to keep me cool. And the other thing is, this topic here for matrices in this IQ has been troubling a lot of people. And I want to make sure I cover up most of the thing because there's so less of you here. I want to make sure I cover what your concerns are because you've been putting in time to come and see what's happening. So why don't you guys go ahead and tell me what you want to kind of cover during this session, because we're going to talk about multiplication and finding inverse in this OQ. But if there's anything else that you feel needs more addressing around the concept of matrix, just post them up in the chat, and I'll be looking over them, and then I'll begin my session after that. So I'm just waiting for you guys to put stuff in the chat. If you don't have anything, just say we need to cover the IQ. That's it, right? So I want to make sure I cover most of the things that are troubling people. Okay, simplification of a matrix. Alright, okay, solving systems. Yeah, that's a completely obvious thing, because most of the time when they teach you these stuff, they don't give you the motivation behind why you need to know this and what's going on. And I'll try to cover that up. Yes, for sure. I'll cover up how do we solve systems using matrices. That was in your OQ as well. Most of the people have kind of trouble figuring it out, but I'll make sure I go over those. Anything else? Okay, I don't see anybody typing anything, which is a good sign. At least we kind of know people are having trouble with certain things or not. But if you're if you want to show off, like tell me what you want to cover up, that's the beauty of the session. We're together here in a meeting so I can address your questions that you guys have, right? So if you have any of the, even if it's a stupid thing like what is a matrix, I completely get it. This is how it's supposed to be. There's no questions that are stupid, okay? You guys need to know what it is, and that's more important than we trying to hold back from asking those kind of questions. So please let me know. Just gonna get rid of this thing. Use my favorite blue color for this. Okay, I'm not seeing any much questions, so why don't we just begin and you guys can ask questions as we go. Okay, let's do it that way. So here, the first question in this IQ is asking for matrix versus matrix, and matrix versus vector multiplications. Okay, so now these names are technical, and I want to make sure. Yeah, a determinant, yes. So I will tell you that too. Don't worry about it. So now matrix and a vector. Well, you guys, before we even begin this whole talk, I want to make sure I take a couple seconds to address what this whole system is about. So I'm going to use a red pen and use this space here to kind of talk about what's happening, and then we'll begin our conversation about solving these questions. So a matrix is a data structure which is mathematical, and it helps you to deal with the data that is condensed in a very specific form. Okay, so we're not supposed to touch too much into this because matrix is a whole topic by itself. Some of you guys taking sciences in future will have to do some courses that involve matrix and determinants, and I will leave that until then. Right now what you got to see is this is a data structure that can be used to apply mathematical operations to a bigger perspective, right? So just like the things they used to do, addition, subtraction, multiplication, substitution, and all those kind of things could be done in matrices as well. Okay, so matrix is usually written like this, where these are the rows and these are the columns. Now, a matrix is identified uniquely by its size. Okay, there's a lot of things about matrices we can talk. The first thing we're going to talk about is the size of a matrix. Okay, a size of a matrix is given like this. So if it has 3 rows, in this case, and 2 columns, it's 3 cross 2 matrix. Okay, so it's a 3 cross 2 matrix in this case, where the first letter here tells you how many rows are there, and this letter tells you how many columns are there, right? And this is how you define a very basic matrix, right? So now matrices are special. They could be having some special names. Some of them are called, like, square matrices, as the name suggests. Square matrices are the matrices that have same rows and same columns, so they make a nice square. In this case, you have a square matrix, which is 3 cross 3 size, right? Because you have 3 rows and 3 columns. So that's just like how you identify these things. The next thing, how is a vector different from a matrix? Okay, because they use this word vector here. Okay, well, a vector is just a matrix, but it only is to have 1 column. Okay, a matrix with 1 column is a vector. Okay, that's the trick. So right now here you have a matrix which has 3 rows because it has 3 sideways entries and 1 column going downward, right? So the size of this matrix, or in other words vector, is 3 cross 1. And the reason why you can call this a vector is because this has only 1 column in there. Okay, so that's the basic difference between what is a matrix and what's a vector. Okay, now that you know what that is, vector is just a subclass of matrix. And keeping that in mind, we can start to talk about what kind of operations we perform on these things, right? You can think of matrix, a data structure. If you think about it, a number system is also a data structure. Okay, so let's say if I think about it that way, let's say you have a number, we're gonna pick 7. Okay, that number itself could be used as a structure to apply mathematical operations. So you can multiply 7, you can add 7 to 7, you can subtract 7 from a 7, you can multiply 7 with a 7 or any other number. Just for the case, I'm just trying to say these are the mathematical operations you can perform on these things. And one important thing that you can do here is 7 could be divided by 7. This is where they're different. In regular world, you can divide numbers, right? But matrices cannot be divided. Okay, that's very important. They cannot be divided. It's just the way how the structure is based and the inherent operations we perform on it does not let us divide 2 matrices. So because we cannot define the mathematical operation amongst these things, what we do is we take a cheeky way around it. Okay, right now if I divide 7 by 7, that's a giant eraser, let me go back to small. 7 by 7 could be also written as 7 times 1 over 7, right? A very fundamental basic operations. What you can say is, if you're dividing 2 vectors, right? You're dividing 2 matrices of vectors. You can basically, what you can do is you can multiply the first one with the inverse of the second. Okay, because matrix multiplication is possible, addition is possible, subtraction is possible. The only thing that's not possible is division. Okay, so what we tend to do is we usually just find the inverse of the matrix that was supposed to be on the bottom, and then multiply the original matrix with the inverse to find that thing. Okay, and I'll show you how they kind of work with the algebra very nicely, just like how you usually think of, right? And now with that basic knowledge, we can begin to start to solve these things, and I'll show you how matrix multiplication happens. Most of you guys already know, very basic trivial thing, but I'll try to give you my take on it. I'm gonna get rid of all of this, and then we'll begin with the matrix multiplication. Okay, the very first thing you gotta identify when you're multiplying 2 matrices is if they are able to be multiplied or not. Okay, and the way you check that is by writing out their sizes first. So this is 3 cross 3, and this is 3 cross 1, right? That's the matrix. A matrix will only be, acceptable for multiplication process if this number and that number matches up. Okay? You can only multiply a matrix if the column of the first matrix is equals to the rows of the first matrix of the second matrix. Okay, that is a very important condition. If you have a mismatch there, you cannot multiply those matrices. Okay, the reason why you cannot do that is because they're describing two different kind of sets, different kind of data structures. Okay, so multiplication happens in a different way for both of them, and you cannot multiply them together into one single data structure. Okay, so that's that. And then the resulting matrix that you will get after the multiplication, okay, will also be a matrix. And the matrix of that size, the size of that matrix, will be given by the outer numbers. Okay, so this matrix will be a 3 cross 1 matrix. Okay, this is how you can identify what's happening here. So now, knowing these tools, this is something you gotta memorize, and it will take some time for you to get used to it, but we'll start off with what's happening next. So here, what they want you to do is find a squared, which is pretty much multiplying a with an a. So we gotta figure out first, can we multiply them at all or no? So I'm gonna try to write this matrix here. That's 3, 0, 1, minus 1, 2, 0, 0, minus 2, 1. This matrix is being multiplied by this matrix again. Again, the order is very important. The way you write them is super crucial. We'll talk more about this as we go. But why do I keep on getting such a huge eraser all the time? 0, 0, minus 2, 1. Well, this is a 3 cross 3 matrix, and this is also a 3 cross 3 matrix. Since this number matches with that, you can go ahead and multiply it. And then the resulting matrix that you're going to get is also going to be a 3 cross 3 matrix because that's the outer numbers. So we're expecting a 3 cross 3 matrix. Now, how do we even compute that thing? So I'm going to try to write it out in a giant matrix first, so you guys can follow along with the method, and then we'll walk towards doing the things quickly in our heads. So because it's going to be a 3 cross 3 matrix, I'm just going to write it down here. You're going to have 9 entries here. 2, 3, 4, 5, 6, 7. Okay, you got to fill in these blanks because it's going to be a 3 cross 3 matrix, so you got to figure out these 9 things. So what we have to see is, if we're looking for the first element here, the very first one, you got to find where does that intersect in the parent ones. So if you see, you take the first row here, and you take the first column, the intersection will be this number. You see that? Because this element here is the intersection of the first row and the first column. Okay, so the first element calculation will be based upon the first row being multiplied with the first column here. Similarly, the second element here is the intersection between the first row and the second column. So this element will be computed using the first row and the second column. Same thing here. For the third element, this element is the intersection between the first column and the first row. Oh, the third column and the first row, my bad. First row and third column. So we gotta use the first row and the third column to identify what's happening over there. And how you do that is, what you do is you multiply the corresponding row elements with the corresponding column elements, and you add the results. So the first thing you'll do is 3 times 3, because the first element of the row with the first element of this will give you a 9. And then the second element of this will multiply with the second element of the column. So 0 times minus 1 is going to give you 0, so plus 0. And then the third element here will multiply by a third here, which is also going to be 1 times 0, so 0. Hence the first entry here will be 9. That's how you compute the first element of this one. Now, similarly, if you're going towards the second element, we got to use this row with this column. So when you multiply the first element of this row with the first element of this column here, you're going to get 3 times 0, which is 0. And then you're going to get 0 times 2, which is 0 again. And you get 1 times minus 2, which is minus 2. So this is just going to be minus 2. And we'll condense that afterwards. The third element is going to be the first row with the third column now. So the first row is going to have the first element 3 multiplied by the first element of the column, which is 1. So you're going to get 3. And then the 0 is going to be multiplied by this, so you're going to get plus 0. And then you get 1 with this 1, you're going to get 1 here. So you're going to have plus 1, a total of 4 there. Now, coming back to the bottom, the second row, for computing this element, this is an intersection between the second row and the first column. So you're going to use the second row here with the first column to get this element. And we're going to do that right now. So this element multiplied by that is going to give you minus 3. This element with this is going to give you minus 2. And then this element with that is going to give you 0. So all in all, you're going to end up with a negative 5 there. Okay. Same thing when you do for the other elements. You're going to keep on following this. This is an intersection between the second row and the second column. So you're going to use second row and second column to compute that. When you do, you get minus 1 times 0, which is 0. You get 2 times 2, which is 4. And then you get 0 times minus 2, which is 0 again. So you're going to end up with 4 here. And now if you keep on doing the same work, I'm not going to keep on explaining it. You got to do the third one all together. So you're going to use this row with that column. So you're going to get minus 1 times 1, which is minus 1, with 2 times 0, which is plus 0. And then you have 0 times 1, which is going to give you 0 as well. So the answer is going to be just minus 1 in this one. Okay. If you compute the same thing again, let me just try to see. I already computed it using calculators and stuff, so that we don't mess up while doing all this work. Just give me a second. Yep, so this and the last will be 2 minus 6 and 1. Yeah, you guys can try to compute that yourself. So this matrix here, when you multiply once, in all its glory will be written out like this. It's going to be 9 minus 2, 4, minus 5, 4, minus 1, 2, minus 6, and then 1. Okay. So this is how you multiply these two matrices. Any questions about this method? Like, how do you multiply two matrices? It's just a computational nightmare to compute these things and add up in the head. Sometimes it takes some time to get used to it, but the method should be kind of clear. Whatever element, first of all, you got to see what sizes are they. When you figure out what sizes are there and they can be multiplied, you got to do the next step. You got to find the resultant matrix's size. In this case, we're dealing with a 3 cross 3, so they can be multiplied. And the resultant is also going to be 3 cross 3 because of this. So we're going to make a 3 cross 3 here. And then, to be able to solve this thing, we need to find all these 9 elements. And we got to check what is the intersection of this element. So this element is the intersection between the first column and the first row. So you use those respective things to multiply and find the result. This is the intersection between the second column and the second row. So you use the second column and the second row to figure out what's happening there. And that's how you solve this. Any questions about this method? What's buzzing in the back? Let me try to see. Yeah, that's my browser. If any questions, just try to put up in the chat, or you can turn on your mic and talk to me, whatever. If not, we'll begin forward. Okay, hopefully everybody's doing good. I don't see any questions there. So this is the answer for a squared. That is the value of a squared. Now, to compute a cube, what you gotta do is you gotta multiply the a squared with a. Okay, this is where I was talking about the order is very important. Okay, since you gotta have a with a squared, you gotta keep the a matrix first and then write the a squared matrix like that. All the matrix operations are performed from the left. Okay, so to find a squared, you would say I can multiply this by a. Well, this is not correct. Okay, a cube will be multiplying a with an a squared. Okay, this is like a different thing that you gotta kind of like train your brain to see in matrices, that the operations that you perform are always performed from the left. Okay, and we're gonna try to write this thing now. So now the new matrix multiplication, this was a squared. Now the a cube is a times a squared. So that will be a matrix A, which is 3, 0, 1, minus 1, 2, 0, 0, minus 2, 1. Being multiplied, well, you don't even need that sign here in this case, with this new matrix that we just found. So 9, minus 2, 4, minus 5, 4, minus 1, 2, minus 6, 1. And now we gotta check whether we can multiply them or not. This is a 3 cross 3, and this is also a 3 cross 3. So we're gonna end up with another 3 cross 3 matrix because of what it is, right? And now we gotta compute these numbers. So to compute the very first element here, we need to use the first row with the first column. So we're gonna have 3 times 9, which is 27, with 0 times minus 5, which is 0, and then 1 times 2, which is 2. So 27 with a 2 will give you a 29 as the first element. Okay, and now we're gonna do the same process for the other ones as well. To find this element, you gotta use this row with that column. So 3 times minus 2 is minus 6, 0 times 4 is 0, and then 1 times minus 6 is minus 6 as well. So all in all, you're gonna end up with a negative 12. Okay, and then we're gonna do one more for this one. Then I'm gonna write down the whole thing because you guys know what's happening. For this element, we're gonna use this row with that column. So 3 times 4, which is 12, 0 times minus 1, which is 0, and then 1 times 1, which is 1. So we're gonna have 13 overall left in this case. That's how you compute each one of the elements in the first row. And then you can do the same stuff for the second row and third row. The elements you should be ending up with is minus 19, 10 for this, minus 6 for that, 12, minus 14, and 3 for that one. Okay, this is basically a cube. So you figured out what a cube is, right? And now the next thing we gotta do is to figure out finally a cube times x. So now we know the x is a vector here, and we gotta see whether we can multiply them or not. So we'll check it out. So here, when you do a cube times x, this will just mean the new matrix that you found for a cube that comes first, which is 29 minus 12, 13, minus 19, 10, minus 6, 12, minus 14, and a 3. Multiplied by this matrix x, which is minus 1, 0. So now we gotta check whether we can even multiply them or not. The first is 3 cross 3. The second is 3 cross 1. So yeah, these numbers match up. We can actually multiply them, right? The resultant is gonna be, however, a 3 cross 1 matrix. So we know we have a 3 cross 1 matrix as the resultant. We need to figure out these 3 elements, right? So now how do you figure out these 3 elements? All you gotta do is, because this first element here is the intersection between this and that. That's the only column you have. You don't have much options. So all you gotta do is you gotta multiply this row with this column and add up all the results. You're gonna get this number here. So the first one is gonna be 29 minus 1, so minus 29. And then you have 12 times 0, which is 0. And then you have 13 times 2, so plus 26, which will give you on top a minus 3. Right? And you can follow the same stuff for the other twos. So because they're easy, I'll just do it for you guys. Minus 19 times minus 1, which is 19. 10 times 0 is going to give you 0. And then minus 6 times 2 is going to give you minus 12. So 19 minus 12 is going to get you a 7. Same thing here. 12 times minus 1 will give you minus 12. Minus 14 times 0 is going to give you 0. And 3 times 6 is going to get you a 6. So minus 12 plus 6 will give you minus 6 altogether. And this is the final answer. So a cube times x is just a matrix which is 3 cross 1 of -3, 7, and -6. That's how you compute a cube x if you follow this algebraic order. Okay, what you did is you figure out the values of a, okay, a squared, a cube, and then multiply with the x later on. Okay, and the next part of this question we'll talk about doing the process with a different kind of algebra. Okay, but before we go there, any questions about this method, about multiplication of vectors with matrices and all that stuff? Okay, hope no questions here, so I think everybody's doing good. We can go to the next one. Okay, now what they want you to do is find the matrix vector multiplication. So what they want you to do is they want you to do the first multiplication with the vector first, and then do the later on. So what they say is, notice that a cube x could be written like this, a times x, because all the operations are performed from the left. So a cube written as a times a with an x, and then you can put brackets around them to kind of find this first, and then multiply that with the a outside, and then multiply that with the a outside, right? Because of the commutative property. So we can do that, and now we can find the vector in a different way. So first of all, let's find ax. In this case, we got to find ax, and ax will be written as a first. So the a matrix is 3, 0, 1, and then -1, 2, 0, and then 0, -2, 1. Yeah, just double checking. But the x matrix here is -1, 0, and 2. Okay, first we gotta check, can we multiply them? I think yes. 3 times 3 with 3 times 1. These numbers match up. We can multiply it. The resultant is going to be a 3 times 1 matrix. Okay, and you know how to compute that. You know how to compute it. You can easily figure that out by doing the same procedure that we did. And those numbers are going to be -1, 1, and 2. Any questions of how I got this? The reason why I skipped it because I've already covered that before, and I'm pretty sure you guys can do it yourself too. But if you still are not too sure about this, just let me know in the chat. I'm waiting for you guys. If you're good, we can just move on. Okay. And then the thing is, you saw this is much easier than doing 3 cross 3. Because when you're doing a 3 cross 3 multiplication first, you have to solve for 9 elements altogether. Right? And then you're doing it again, so you got to solve for another 9 elements again. And then you multiply the vectors at the very end. In this case, you only have to solve for 3 of them. Right? So only 3 elements is supposed to be found out. Here we were supposed to only find 3. And now, since we have the ax, what we can do is we can multiply the a with the ax now. So a with the ax would just be writing the a matrix again. 3, 0, 1, -1, 2, 0, 0, -2, 1. With the ax matrix that you just found out, which is -1, 1, 2. When you do that, you can multiply them because it's a 3 cross 3 with a 3 cross 1. You know the resultant is going to be a 3 cross 1 matrix, and you can compute those individual elements super quickly by doing the math again. So I'm going to do that right now with you guys, just so that I know, make sure everybody's getting it. So the first element is computed by this row with that, so we're going to have -3 with a 0 and a 2. So -3 and 2 will give you a total of -1. And now, the last thing you're going to have here is with the -1 with this, 2 with that, 0 with this. So -1 times -1 is going to give you 1. 2 with 1 is going to give you a 2. So 1 with 2, you're going to get a 3 there. And the next thing, the last one, is going to be multiplication of this with that. So 0 with minus 1 is going to give you 0. Minus 2 with 1 is going to give you minus 2. And 1 with 2 is going to give you 2. So you're going to have minus 2 and a 2, which is going to give you 0. In this case, so this is a times ax. And now finally the a cubed times that thing could be figured out by just multiplying this with the A matrix. So a times a of x could be figured out because we know this matrix is just that thing here. So we're going to use that handy. 3, 0, 1, minus 1, 2, 0, 0, minus 2, 1. Multiply with minus 1, 3, 0. Will give you another matrix where 3 times minus 1 is minus 3. 0 times 3 is going to give you 0. So you have minus 3 on top. You got minus 1 times minus 1, which is 1. 2 times 3, which is 6. So 7 in total here for that. And then you're going to have 0 with minus 1, which is 0. Minus 2 with 3, which is minus 6. This with 0, so the total is minus 6 at the bottom. So now you got the result much faster, because the only thing you have to compute is just 3 elements when you do the multiplication, right? So this answer here, minus 3, 7, minus 6, is exactly same as minus 3, 7, minus 6 here. Because of the algebra, it works that way. It's not a big difference if you multiply a with x first and then put the a application on top. The reason why you will prefer to do this is because it's computationally faster, and the reason why it becomes faster is because if you choose to multiply a matrix with a vector first, you will always get a vector. Okay, that's the beauty of it. So a matrix with a vector will give you a vector, and then that multiplication is faster. So when you do another matrix multiplication with this vector, you're going to get another vector, and you're going to get the same thing here. However, in the previous case, you were multiplying a matrix with a matrix. So you're going to get a matrix, and then you multiply that matrix with another matrix to get a matrix, and then at the end you multiply a matrix with a vector to get a vector. So it's better to do the matrix multiplications in the very least at the very end. So try to get the vectors first, and then move back towards the matrix multiplication. So that's why it already answers your part C, while matrix vector is faster, or like fewer calculations. Then matrix multiplication. And I hope everybody understands what's going on here, right? The reason why we can do that is because we already saw that on top. Any questions about this first go? If not, we can move ahead. Okay, there's no questions here so far. So what I'll do is I'll begin solving the second one. Here, the second question is about inverse matrix. Okay, and inverse matrix is just another way of writing. You know, I already justified why you need an inverse matrix. I don't have that work here anymore. But the inverse of a matrix is required to carry forward division process in deceiving the system. You can to divide A with something other that's a matrix, what you can do is you can multiply A with the inverse of that matrix. Okay, so that's why finding inverses are very important. That's number one. And then we'll come back to why you actually need to do this for solving equations, and I'll show you that too. So don't worry about that. We'll jump onto those. First of all, we got to talk about this determinant here. So determinant is a mathematical quantity. Okay, it's a quantity that kind of condenses the matrix into something that's a value. I don't want to go too deep into this, because what it does is, okay, just like super quickly, if I was to tell you, you don't have to remember this, you don't have to memorize what's happening here. This matrix here, I'm gonna use a laser because I want to make a mess here. This matrix here, all of these columns are individual vectors. Okay, 0, 3, 1, minus 1, 1, 2, 2, 2, 0. These are three vectors. They're individual vectors combined into one single matrix. Okay, these vectors are three-dimensional because they have three coordinates here. These three-dimensional vectors in a 3D space, let me just try to draw that here. In a 3D space, will make a shape. Okay, and if you try to close that shape, you'll see it's a parallelepiped in 3D. A parallelepiped is just like a parallelogram that you usually see like this. A parallelogram, but in 3D. With individual these vectors as its basis, and the volume of the parallelepiped is what this determinant is. Okay, too much words, too much information, which you don't need. So that's why for us in this course, determinant is just basically a number that quantifies something, and we can make conclusions on that quantity. The only thing that you will be interested in finding is if the determinant of a matrix A is 0, then it's not invertible. That's it. That's the only thing you gotta do. Okay, so for our matrix to be invertible means you can find its inverse. You have to see whether, you know, its determinant is 0 or not. And the reason behind why we do that is something that you guys don't learn in this course. The method of finding inverse using determinant is also an approach of finding inverse, but you guys don't learn that. You learn this method, and which doesn't have any determinant involved into this. So this process of finding an inverse could be broken down to two steps. You find the determinant to verify whether you can actually find an inverse or not. Once you've satisfied that you can find the inverse, then you can start to apply these operations to find it. Okay, and that's the only significance of determinant. And the way you compute the determinant is based upon my kind of like imagination. That's the way how I do it. Your prof kind of tells you the square matrix like this, but what I tend to do is when you have a 3x3 matrix, what you do is you take these numbers in the very first row and you write them out like this: 0 times something. Okay, the next one is a -1. Okay, so it has a already, by convention you should have a minus there too. Okay? It's like an alternating sign. The first one was positive, the second one will have a negative in front of it, the third one will be have positive, and if you have the fourth you will have a negative, and it goes on so on, right? So that's a negative there, convention, being multiplied by something. And the last thing on top is 2. So plus 2 multiplied by something as well. Okay. Now what are those things in the brackets is something you figure out by avoiding those two things. So if you see 0 is an intersection of this, so you forget about these first two columns and rows. Okay. Once you forgot about these, all you gotta do is you gotta find the cross product here. So 1 times 0 minus 2 times 2. So 1 times 0 minus 2 times 2 is what you're going to put up there. 1 times 0 minus 2 times 2. Okay, that's how you figure out the first one. So now what comes in the second column is you ignore these two. So you ignore these two, and then you do the cross product here. So 3 times 0 minus 1 times 2. So you're going to have 3 times 0 minus 1 times 2. Similarly for the last one here, you're going to ignore these things, and you're going to cross multiply this 3 with 2. So 3 times 2 minus 1 times 1. So 3 times 2 minus 1 times 1. That is how you compute a determinant in my own kind of way. There's millions of videos out there telling you how to compute it. Either way is fine. I just choose to do this way. So now let's compute what these things are going to be. Well, I don't care about this because it's going to be 0. It's multiplied by 0 anyways. So that is going to be 0. However, this is going to give me 3 times 0, which is 0, minus 2. So in all, we have minus 2 inside. And this minus 2 multiplied by minus 1 with a minus is going to give me minus 2. So that's the first thing here. This all is going to be minus 2. The last term here is 6 minus 1, which is going to be 5. And 2 times 5 is 10. So plus 10. So we're going to have minus 8 as the determinant of this matrix. Not minus 8. Plus 8, my bad. 10 plus minus 2 is this, so plus 8. And that is how you compute the determinant. Any questions about this? There's a different way of your prof probably talking about it. Whatever you feel comfortable with, you can go ahead. I just compute it this way because it's just faster to think about it. There's other videos as well where they write the matrix in a different way and they do the arrows to figure it out. But if you need more resources on how to find these determinants, just let me know. Send me a message and talk to me about it. I'll tell you, I'll try to explain what's bothering in this whole process. But this is how you pretty much find the inverse. Now that we've figured out the inverse and it's non-zero, it's 8, hence this matrix is invertible. Okay. So now that we know it's invertible, we can find its inverse. And the way you do that is by applying operations. We gotta apply elementary row operations, and we'll talk about that in a second. First of all, we gotta make sure how does that even work. Okay. When you say you have a number 7, let's say you had number 7, and you multiply that number by its inverse. Okay. So same number multiplied by its inverse. So the inverse of 7 is 1 over 7. The result of these things is going to be 1, right? So anything multiplied by its inverse is going to give you 1. That's just a property, right, of what an inverse is, pretty much. Now, if you think about it, then A multiplied by A inverse must be equals to 1, right? Because if A is a matrix, you multiply the inverse of the matrix with the matrix itself, you're going to get 1. And how do we define 1 in matrices? Is by using the letter I. I stands for identity matrix. Okay, the identity matrix is nothing but a matrix that is the same size as A, but has 1s on the main diagonal and 0s everywhere else. Okay, so 3 cross 3 I, or 3 cross 3 size I, looks like this. This is the identity matrix. Now, using this fundamental, what we can do is, because of this statement being here, what you can do is you can find the A inverse by finding it this way. So what I'm going to show here right now is like this. So they said you make an augmented matrix like this. So A with the I, right? That's the matrix here. So the augmented matrix is like this. If you multiply both the sides by A inverse, then this will become I, because A inverse times A is I, and any matrix multiplied by I will be the same matrix. Okay, it doesn't change anything over there. So that's why this side will now become A inverse. So if we can somehow swap these positions here, the matrix on the right side will become A inverse. And that is the fundamental behind why we're doing this. Okay, so we'll try to do that right now together. This is where it's going to be a little bit lengthy process, so we're going to make sure I use the space optimally to figure out what's going on. So first of all, we got to make an augmented matrix here. The augmented matrix will have A on one side, which is this. So 0, minus 1, 2, 3, 1, 2, and you have 1, 2, 0. Okay, so this is just A matrix, but to make it an augmented one, I'm gonna have a blue line in there to just signify that there's a difference in there. And the identity matrix on the right side will just have 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is A with the I matrix here. Okay, so if I can somehow turn this left hand matrix into I, then the right hand matrix will automatically become A inverse because they're equivalent operations. So that's what I'm going to be focused towards. And let's see how we can actually figure that out. For making an identity matrix, I want to have turn these things into 1, 0, 0, 0, 1, 0, 0, 0, 1. That's what I want to turn them into. And you can apply elementary row operations, which means you can swap the rows, you can multiply either of the rows with a constant, you can subtract or add rows with each other, okay, or a combination of all these three. These are the basic elementary operations you can perform. Okay, now because what I can see is because I have a swap here to help me out, I need a 1 there on top. Okay, so I have a 1 here in this row. What if I can switch this on top and swap it to the bottom? I can do that here. So now we got to label all the operations that we perform. Okay, the operations are going to be labeled like this: R3 swap R1, because the R1 is the first row and the R3 is the third row. Okay, we're swapping them. So R3 R1. And then the new resulting matrix that you're going to get here is going to look something like this. We'll have the third row on the top and the first row on the very bottom. So we're going to have 1, 2, 0, 0, 0, 1. Of course, the line in the middle. This row will stay like this. And then you're going to have 0, minus 1, 2, 0, 0, 1. 1, 0, 0. So that's the first operation. Yes, there are absolutely a million ways to do this, and you can follow any of the ways you can. Okay, as long as they're elementary and they can, get the same results, it's going to be completely fine. You're going to see it eventually adds to the same thing. So instead of trying to compare your work with somebody else, just try to say, like, if you follow the right thing with the same algebra or not. As long as that's correct, you're going to be good. Okay, so let's move forward. That's the first one. And now the rule of thumb is to make it into row echelon form. Some people might find it confusing. And the way you do that is by actually, making this main diagonal, the elements before the main diagonal 0. Now we already have one of them to be 0. And to make 3 into a 0, what I can do is I can multiply this 3 times and subtract it from this row. Okay, I can use the elements on top to help me out with this. Okay, so let's do that. The operation that I'm performing here will be written as the R2 will change into R2 minus 3 times R1. Okay, so I'm multiplying the row 1 by 3 and then subtracting it from the row at the bottom. Okay, so this will give me a new matrix here. The new matrix will have it this way. So the rows that are not changing are going to stay like this. Okay, so R1 does not change, it's going to stay like this: 1, 2, 0, 0, 0, 1. I'm going to write the R2 in a second. R2 is changing, so we'll do that, but I'll do the third one first. This is 0, minus 1, 2, 1, 0, 0. So these are the rows that didn't change. The one that changed, however, will have a 0 here first because of the operation that we performed. This element, however, this element will just become, my 3 times 2 is going to give me 6, and then 1 minus 6 is going to give me minus 5 there. Minus 5 there. And this element here will be figured out by doing 2 minus 3 times 0, which is 0, so that's going to stay as 2. Not going to change at all. Here, you're going to end up with this 0, 1, and minus 3 times R1 will give you minus 3 times 1, which is minus 3. Added up with 0 will give you minus 3 there. So you have minus 3 in this. So you successfully turned up the first two into zeros now. The next one on the list is this guy. Okay, and the next one on the list is this guy. How would you convert that into a zero? And that is where a lot of people will have kind of like a second thought about what they're doing. But it's not going to be that bad, trust me. And we'll figure out a way for this. What you can do though, I'm just trying to figure out which is the easiest to, go around this. Because we're going to end up with fractions. So I tend to avoid them until the very end, but sometimes they're not avoidable. In this case, it's not. So what I'll do is, I will perform this operation here. The operation will be that R3 changes into R3 minus R2 divided by 5. Okay, because if I do that, if I divide the second row by 5 and then I subtract it from the third row, then I'm gonna have this element turn into 0. Okay, and let's see how we can try to figure this out into a new matrix here. So I'm gonna write the rows that didn't change. So 1, 2, 0, 0, 0, 1, 0, minus 5, 2, 0, 1, minus 3. And now this is gonna stay as 0 because the top element is 0. You're not subtracting anything from it. This, however, will make it so R3, which is minus 1, will take away minus 5 divided by 5, which is minus 1. So you take away minus 1 from minus 1, you're going to end up with 0. Same thing here. If you divide it by 5, you're going to take away 2/5 from 2. So you're going to end up with, I guess, so I'm just going to do it roughly here. 2 minus 2 by 5 will give me 10 minus 2 by 5, which is 8 by 5. So I'm going to end up with 8 by 5 here. 8 by 5 here, which is going to give me, in this case, 1. This is 1/5 minus 1/5. And then you're going to have, just going to try to mute Jordan Jacobs, so you can hear some stuff in the back. Yes, so the reason why we want to make them 0, because for an identity matrix, right, these things are 0. So you see that these are 0 for an identity matrix. So we want to make this into an identity matrix eventually, right? So if we can make this side as an identity matrix, then the other side automatically becomes A inverse. So we're just trying to make sure all the elements become what we're trying to, focus towards. That's just that. Okay, we're good with this. Now, we got 8 over 5 for the first one, and then this stays like 1 because it has nothing on top. This becomes 0 minus 1/5, so that's minus 1/5. You have 0 minus 3/5. So we're going to have plus 3/5 on this here. Okay. And now, once this is completed, the last row needs to have a 1 at the end because the identity matrix has a 1 here, right? So I want to make this into 1. So what I can do is I can perform an operation that tells me that R3 changes into, to make 8 by 5 into a 1, I can multiply this by 5 by 8. Okay, so R3 changes into 5/8 times R3, so that I can have a sweet 1 down there. So once we do that, our new matrix will be 1, 2, 0, 0, 0, 1, and then 0 minus 5, 2, 0, 1 minus 3, and then we're going to have 0, 0, 1 here, because the operation that we perform is going to give us a 1. And then we have 1 times 5/8, we're going to give 5 over 8 here. This minus 5, minus 1 over 5 times 5/8 is going to give me minus 1 over 8. And this operation right here is going to give me 3 over 8. So far we're good. We made this thing look like an entity matrix, right? The next step is to make this guy into 1, because that's supposed to be. So what you can do is you can perform an operation again. You can say that R2 changes to R2 divided by minus 5, right? If you do that, then you're going to end up with 1 on top in the middle. So we do that, the new matrix that we're going to get is 1, 2, 0, 0, 0, 1, 0, 1, and then you're going to have 2/5. Negative 2/5 on this with a 0, 1, 1 by 5th, minus 3 by 5th, and then the bottom part is going to be 0, 0, 1, 5/8, negative 1/8, 3 by 8. Okay, that's what's going to happen here. So this is the new matrix so far. And now we're going to make this into 0 because the identity matrix tells me to make this into a 0. Okay, so what I'll do is I will take the row 3 and take a help of that to get it to 0. What I can do is I can find an operation. I'm definitely going to run out of space. That's usually what happens with me when I'm solving matrices, because I write them so big. But yeah, the next operation would be to change R2 into, so to get that result you want to add 2/5 of R3 into it. So R2 plus 2/5 of R3. So the negative 3/5 is supposed to be positive. Let me see. It could be I made a mistake here. So talking about this one. Oh yes, thanks for correcting me. We could have gone downhill from there, but it's 3 by 5. Very thankful for correcting that out. That's good. 3 by 5, good. Now I can move ahead. This is going to be a new matrix. The first row doesn't change. 0, 0, 1. Second row is what's going to change. So this is going to stay as 0. And then 1, because this 0 doesn't have any element play in there. And this will give you a 0 here too. Now the tough part is to compute all of these ones. So I'm going to take a second and I'll do that. Roughly 0, 0, 1, 5/8, negative 1/8, and 3/8. So now individual elements is supposed to be calculated. And I'm going to do that now. So we have a 0 here, and you're going to add 2/5 of 5/8. So you're going to have 2 by 8 on top. And then for the other one, you have 1/5 already there. So 1/5, you're going to add a 2 by 5 of minus 1 by 8. Okay, and this is where it becomes very nasty. I would need to use some help of the calculator to kind of get through this. Let me see what I can do. So they want us to do R2, which is 1/5, plus 2 by 5 of negative 1/8. So we're going to have 1/5 plus minus 2 by 40. So that's 1/5 minus 1 by 20. And that's going to give me 4 by 20 minus 1 by 20. Is it correct? Maybe? Let me try to check. Gotta have decimals on side of me to kind of figure out what's happening. So you get minus 2 divided by 5. One fifth plus 2 divided by 5. But yeah, it was correct. 3 by 20. Three by 20 there. So 1/5, not negative for R2. That is an excellent question. I think it should be. Because that's what I was thinking. Like, my method is giving me a weird number. Usually they don't. And it's correct. Should be a minus 1/5. I'm tripping already. You see that? Should be minus 1/5. And that's going to make me do the calculations again. So I'll do it again. Minus 1/5 plus 2/5 minus 1 over 8. Which is going to give me minus 1/5 plus plus minus 2 by 40. So minus 1/5 minus 1 by 20, and that's gonna give me minus 5 by 20. That's minus 1/4. So that should be minus 1/4. Thanks for correcting me out there. Minus 1/4 is supposed to be there. Good. And now that I've already confirmed, you guys are smarter than me, that you have 3 by 5 figured out as positive. So we can work on calculating that. So 3 by 5 plus 2 by 5 of 3 by 8. So we're going to end up with 3 by 5 plus 6 by 40, which could be reduced into 3 by 20. So 12 by 20 plus 3 by 20, which is going to be 15 by 20, could be reduced into 3 by 4. Yes. So the last entry is going to be 3 by 4 here. Oof, that's ugly. But yeah, that's how we figured out the first two rows here of what's going on. Now the last step will be to use to make this 2 into a 0, and that could be done by this operation here. The final operation that we're going to perform is to change R1 into R1 minus twice of R2. Okay, so we got to do that, because doing that twice will give me the same result. So geez, how do I write this into a smaller space? I'm just gonna try to zoom in here. Can't zoom in. Let me try to use these fancy tools that I have to see if I can squeeze some more space in there. Oh, that's nice. I can squeeze this there, and then I can squeeze this, all of that. Into somewhere here, and then I can write my final result in all its glory. So the rows that don't change will stay like that. I'm gonna write the last two first. 0, 1, 0. I'm gonna try to simplify them into as simple forms as I can, because 2 8s could be written as 1/4. So 1/4 minus 1/4, 3 by 4. And then you have 5 by 8. That's the simplest you can write that. Minus 1 by 8, 3 by 8, 0, 0, 1. And now this side on the top will have 1, 0, 0 because of this operation. And now we're going to compute these first two are super easy. Just going to multiply this entry by 2 and subtract it from the top. So we're going to have minus 1/4, minus 1, 2 on top. This subtracting will give me plus 1 by 2. And the last entry will just be 1 minus twice of 3 by 4th. So 1 minus 3 by 2 will give me negative 1/2. So now that you've reduced it into these two forms, what you can say, if this is identity, hence this is A inverse. So the A inverse, if you were to write that separately, will just be this. Minus 1/2, 1/2, minus 1/2, 1/4, minus 1/4, 3/4, 5/8, minus 1/8, 3/8. And that is the inverse of this matrix. A heck of a long way to compute this, but you can always check these results from your online calculators. I'm pretty sure this is correct. But that's how you find an inverse of a matrix. With that, we've concluded this IQ. So now, any questions about what's happening here, apart from my stupid brain tripping on weird algebra, forgetting out negatives and positives? If you have any questions, you can ask me down here right now. If not, we're good to go. You guys can leave the meeting, and thank you for tuning in. And once everybody's gone, I'll shut it off, but I'll wait everybody to send up their questions. Yes, as Danny asked, the best way to see those patterns and order of operations is just to practice them. Try to make sure you see enough of these questions so that you build the intuition of why somebody did this that way, and why is that faster than what I know. It's just because of practice you'll get better at this. There's no other way, because this is just plain algebra, right? If you guys can see those patterns better than me, kudos to you. But I'm pretty dumb with algebra, as you can see. But yeah, that's just how it goes. There you go. You guys are welcome.